Yo, what's up, everyone? Here we are with our post-Thanksgiving work and a new unit. So not everyone has finished quadratics yet, and that's fine. Just make sure you're getting there soon because we have 3 weeks I've planned out till Christmas, which is a time that you might not be in the mood for school. But if you try to leave everything till after Christmas, it's going to be a lot. Um, So if you were hoping we'd stop graphing, my bad news is that the next 3 weeks we're going to continue graphing, but the second half of the year is going to be less graphing. So we're kind of crushing it, and I think that what we have going for the next 3 weeks is going to be some really good stuff. And like always, I'm really just going to encourage you to come to office hours, because, I mean, to be completely honest, I've been struggling. And what I think is really missing from my life is kind of interacting with students, talking to students, um, because that's why I signed up to be a teacher, right? To help you guys through your lives. So while I do think the videos are good, and I appreciate the people who are watching, because I know that's not even everyone. In Algebra 2, we're struggling. I think it's like a third of you are actually watching the videos. But if you're one of those people who's watching, I really, really appreciate that you're taking this seriously. And I would really appreciate if you, before we go back to real school, met up with me at least once to just kind of talk about life. So what I want you to first notice is this worksheet's going to look intimidating. We have a completely new kind of function, which we call a rational function. And this whole first example is going to be our way of trying to figure out how to graph something that looks like this, okay? And as always, the first example is going to be the hardest, and then you can even look through the next few examples. They're going to be quick. There's not a whole lot that you need to know or like the skills for this unit, but the logic here is really important. So that's what we're going to start with. So just as what's been going on, we started with linear equations, something like y equals x plus 2. We then did quadratics, something like this, with an x squared. And both these units you probably had already seen before, right? This is stuff that you do in Algebra 1 as well. So we're now looking at things that you might have never seen before. And this is our next type of function, which we call a rational function. And all that's happening here, all I want you to notice is that we're still seeing something really basic. We're seeing x plus 2. But that x plus 2 is on the bottom of a fraction. So all rational functions are going to be functions with a division sign. And for now, it's always going to be a number on the top and then the x on the bottom. And this is simple. It's just x plus 2, right? It's not something really complicated on the bottom. So we're trying to graph this. That's our goal. And we're going to try to graph a few of these and learn their shortcuts. But what I want you to realize, and this is something to remember always, is that if you ever want to graph something that you don't know how to graph, all you have to do is plug in points, okay? You could get a crazy equation, but if you know how to plug in certain numbers, just any numbers really, into your calculator or whatever, you can graph any function by plugging in points, okay? Because all a function is, all a graph is what's happening at every x value as we go from negative infinity to infinity. What's going to happen to our y? So we're going to start, and I'm going to use my graphing for like a little fancier of a calculator. We're going to plug in all these x values into my equation to see what the shape of this is going to be. Because the key to this unit is remembering what the shapes are, right? Linear is just a line. Quadratics are a U or a hill. And a rational function, we want to figure out what it's going to be. So I'll just start with negative 10. If I want to plug negative 10 into the equation, let me just do it over here. It's going to be 1 over negative 10 plus 2, right? And I do apologize. I didn't figure out how to get my better software to work, but I'm better at this one now. So negative 10 plus 2 is negative 8 on the bottom. So this first one is just going to be negative 1/8, okay? And for now, let's just put them all in decimal so we really understand. what's happening. So when x is negative 10, y is negative 0.125. So it's pretty close to 0, but it's a little bit below 0. It'd be something like that. Hopefully everyone understands what I'm doing. If you plug in any x value, you could have chosen your own, but I'm choosing kind of the best ones. You can get a shape. So let's do the next one. Negative 5 plus 2 on the bottom. So it's going to be negative 1/3, which is negative 0.333. So when we're at negative 5, it's still really close to 0, but it's not as close to 0 as negative 10 was. I'm just going to keep going. Negative 3 plus 2, this is going to become negative 1, because negative 3 plus 2 is negative 1. 1 over negative 1 is negative 1. Now, we're going to skip negative 2 for now, okay? And maybe you can already see why. Think about what's going to happen when we plug in negative 2. But if we plug in negative 1, it's going to be 1 over negative 1 plus 2, which is 1. So at negative 1, our graph is 1. And at 2, it's going to be 1/4. And at 10, it's going to be 1/12. So I did that fast, but hopefully everyone is kind of understanding how I'm doing it. Now, what's kind of difficult is we tried to sketch this and we get these points and then these points. So is it going to be like this? It's tough to say. But let's talk about what happens if we plug in negative 2 into the equation, because that's going to give us a little clarity. So if we plug in negative 2 to this, what's going to happen to the bottom of my fraction? We're going to have y equals 1 over negative 2 plus 2. Negative 2 plus 2 is 0. So it's 1 divided by 0. Okay? And remember that you cannot divide by 0. If you see something like this, that's going to indicate that it's undefined. It doesn't exist. And I hope you remember that from the past. You can do something like 0 divided by 1. That's just going to be 0. But 1 divided by 0 is undefined. It doesn't exist. Okay? So if I wanted to plug something in for negative 2 for x, I can't. There's nothing I can plug in because 1 divided by 0 is undefined. So we want to figure out why that's happening. Okay? But what we're going to do first is any point that's undefined, we're going to draw a line, a dotted line, and that's going to indicate we can't touch that line. Okay, this isn't the same as the axis of symmetry, so you have to be aware of what unit you're dealing with when you have dotted lines. But we know that x was never going to equal this point, so we're going to make a dotted line. So we're just going to continue here and plug in some more points. These next 4 points, what I want you to notice, and this should say negative 2, is what's going to happen as we get closer and closer to this point. We know that we couldn't plug in negative 2, but we can plug in points that are really close to it, right? So if we plug in negative 2.5, for example, it's going to be 1 divided by negative 2.5. And that's going to be 1 divided by negative 0.5, which is negative 2. So we get halfway here. That's this point. But what's going to happen if I plug in this point that's really, really, really close to negative 2? So negative 2.000000001 plus 2. So we plug that into the equation. And the negative 2.00000 is going to cancel out. But we're going to be left with 0.1 or 0.00001 on the bottom. And I hope that makes sense to everyone. If it doesn't, definitely look on this on your own. But if we plug in a point that's really close to negative 2, it's going to result in 1 divided by a really small number. Okay? So if we have this really small number on the bottom of my fraction, what happens? You have to remember that a small bottom number, a small bottom fraction, is going to make this answer way big. So if I do 1 divided by, and let me just do a side example. I'm hoping this is clear. We'll definitely have a calculator out so that you can kind of see this on your own. But as you put a smaller and smaller number in the bottom, that's getting closer and closer to 0, that means that the answer is going to be bigger and bigger. Okay, so the bigger the top number is, obviously the bigger the number is, but a property of fractions is that the smaller the bottom number is, the bigger the number gets. So 1 divided by 1 is obviously 1, but 1 divided by 0.5 is 2. And then 1 divided by 0.1 is 10. So this number is getting bigger as this number gets smaller. So much so that even if you put in like 0.0001, that means 10,000. So how does that relate to this? And this is really important to understand, and I think it's fascinating. If we're trying to sketch this, think that as we get closer to -2, the number is going to get smaller and smaller because these are negatives. So it's like everything I just did but negative. So it's -2, then -5. It's going to get closer and closer to -2. Or sorry. Before I do that, I just want to be clear. Like if the bottom's negative, it's going to be a negative number. So the number is getting bigger and negative. Okay. So think that as my line is getting closer and closer to -2, the number is getting bigger and bigger or more and more negative. Okay. So this is what the shape is going to be. And it's going to be pretty easy eventually, even the next example. But the reason for that is that if we plug in a number really close to -2, it's going to result in a huge number. Now let's see what happens on the other side. Now it's going to be the positive example. So we know we can't be -2, but what if we're -1.9999999? That's just going to result in 1 divided by a positive number on the bottom. So something like positive 10,000. And this is one of those things, if you're watching, just make sure you understand that logic. But the way these graphs work is you have to find what's called the asymptote, and it's going to go crazy close to the asymptote. So right on the other side of this, the number could be as big as 10,000, right? But as we get closer and closer to normal numbers, it's going to get back to the other points. So hopefully that makes sense, and that is what it's going to look like. But as we get close to -2, the number either gets really big negative or really big positive. So that's the first thing to notice. And this is actually what it's going to look like. But there's one other value on this that we can't equal, and we're trying to figure that out next. So I think this is really fascinating. We already talked about what's happening at -2 for x, but what's happening to my line on both ends? And as we go closer and closer to infinity and -infinity, we want to figure out what are we approaching on this. And just by looking and from what we talked about, it's 0, right? As the number gets smaller, like more and more negative, it's getting closer to 0. And on the other side, as the number gets bigger and bigger, it gets closer and closer to 0. So what I want you to think is what happens if we put in a huge number into my equation. So this first one, if we put in -1,000, we add 2, it's going to be 1 divided by -998. And if you have a really big number on the bottom of a fraction, that's going to mean that the number itself is really small. So there's two really important properties of fractions, and that dictates the entire logic of this. If you have a huge number on the bottom of the fraction, it's going to result in a number that's really close to 0, okay? And I hope that makes sense to everyone, because when we do the work, it's going to be really easy. But as we get closer and closer to infinity, as we go all the way this way and all the way this way, you need to think that the number or the fraction is going to have a really big bottom number, okay? I don't know if I explained it perfectly today, but I think that if you're really wrestling with the material, it should make sense. But something to realize is that we're never going to be equal to 0. And that's why we're going to put an asymptote here or another dotted line. Think that even if I put in like infinity or a million, it's not going to be 0 because it's going to get really close to that, but it's not going to be exactly 0. 1 divided by a million is like 0.000001, right? But it's not 0. So what's really fascinating about these rational functions is that we're constantly looking to see what values are we approaching. On both ends, for today at least, we're always going to go to 0, but we have to figure out what x value we can't equal. So in this case, the x value we can't equal is -2, and the y value we can't equal is 0. So that's all the logic. And I can't really tell my time with this new software, but I think that was a long example. And as always, we talk about the logic first, but now we're going to talk about how you can do it yourself really quickly. So for the rest of these, you're not going to have to use a table. We use the table for the logic to understand what's happening. But all you have to do if you want to graph a rational function is figure out your two dotted lines, which are the asymptotes. So if I'm looking at this, the question you have to ask yourself is what value can x not equal? And that's whatever value makes the bottom of my fraction equal to 0. So the bottom of a fraction can't equal 0. So this is just like finding factors and x-intercepts from factors. It's constantly the same things. X can equal -6, right? Because that would just be -12 on the bottom. But x cannot equal 6. Because if x is 6, 6 minus 6 is 0, and we have 1 divided by 0, which can't work. So the x asymptote is whatever value you can't equal. We say the x asymptote is x equals 6, but we know that that means that no value on my line is going to equal that point. The second asymptote is the y asymptote. And the good news for today is that it's always going to be equal to 0. That'll change next lesson, but know that if you put in a really big value here, it's going to result in a number close to 0, but not exactly 0. So the asymptotes are just the points we can't equal. Once you have that, I'm here to tell you that graphing it is really easy. Okay, it's like sketching where we don't know exactly what it's going to look like, kind of like a quadratic, but we know that it can't equal this point, so it's going to get really close. And it can't equal this point, so it's going to get really close. So you're just going to sketch a line that gets close to both of your asymptotes up here and then over here. The positive, positive, and the negative, negative. And that's all you would have to do. So if you're like, wow, that's really easy, make sure you understand why. Go back and make sure you understand why this works. The next two examples are just going to clarify some things you could see. And here we see a 4 on the top, not like a number 1. And I'm here to tell you that the number on top does not matter, okay? And it never will, okay? This top constant, it's just a 4. We don't care. If you think about it, if we put in a million here, 4 divided by a million is pretty much 0, the same way that 100 right? These are both basically 0. So we don't care what the top number is. All we care about is what's happening on the bottom. We know that x can't equal -2 here, and that our asymptote is going to remain 0. So this is actually going to graph just like example number 1. It's going to look pretty much the same. And then once you draw on your asymptotes, you're just sketching what the rest of it is going to look like. Cool. Last example here is a negative example. And the short answer is it's just going to flip where you actually put your lines. But I want to talk about why. Just think that first, we don't care about the top. Yeah, actually, first, let's just find our asymptotes. If we have x plus 3 on the bottom, we know that x can't equal -3. And no matter what, the y asymptote is 0 for now. So those are my asymptotes, which guide how I graph my rational function. But what I want you to think is that a positive goes here and here, but a negative is going to go here and here. And very quickly, the reason why is, let's just imagine you put in like 10,000 here. It's going to be a small number, but it's going to be a small negative, okay? That number is getting really close to 0, but on the negative side of the equation. If every number was positive before, on the right side, it's now going to be negative. All right, that's that. I think my explanation was only okay, but this is confusing conceptually. But I think if you wrestle with this yourself, you're going to be really good. All right, we're out. Woo!